Good evening, everyone, and welcome to this session, our masterclass in robotics. We're very excited to have you and to have a really wonderful speaker with us today. Before we begin, I will go over some housekeeping announcements. So to avoid distractions, we request you to keep your camera and audio off. They are muted by us, but just be mindful of them as well. Please post your questions in the chat box for the Q&A segment. This is a great opportunity to ask questions from, an experienced expert in the field. So do, listen to the session first and then keep your questions relevant and post them in the chat box at the end. You may want to use headphones for enhanced audio quality, and we will be posting some information and links in the chat box as well. So do look out for those as the session progresses. Before we begin, I'd also like to briefly introduce Education USA to you. Education USA is a US Department of State supported network, and our mandate is to provide accurate, comprehensive, and current information. It's a global network with over 430 centers in over 175 countries. In India, Education USA is based in New Delhi with an advisor in Mumbai. And Education USA India is a US mission-supported platform that advances US leadership in higher education, research, and innovation. We connect India's academic and research ecosystem with American excellence aligned with US foreign policy and public diplomacy priorities. You can stay connected with Education USA in a variety of ways. You can scan this QR code to sign up for updates. You can also follow us on social media. We're usually found at the handle Education USA India, so you can look out for that on YouTube, Instagram, Facebook, and Twitter, and follow us to get updated on our events. So just to say, we conduct a variety of events, like this masterclass, state spotlights, sessions on sports, within the academic environment and so on. And so those are the kinds of sessions that you can keep in touch with through our various series that we conduct. For today, we have a masterclass in robotics, and I'm sure, we've had a really great response to this session, and I'm sure, as you all know, I think at one time robotics was the stuff of science fiction, but today it isn't that. It is much more present to our lives, and we're going to examine the foundational concepts of human-robot interactions in today's masterclass. And so we have on the screen the agenda for the session. We will start with the tutorial in human-robot interactions, and then for about 10 minutes, we will just do a quick overview of research and opportunities in robotics in the US and US leadership in this field, the state of play, what are the cutting edge developments in the field in the United States. And then we will close out with 10 minutes for Q&A. And so that brings me to our expert for today. I'm very pleased to introduce to you Professor Ramana Vinjamuri. He is the Associate Professor of Computer Science and Electrical Engineering at the University of Maryland, Baltimore County. And he has quite a long resume, which kind of showcases, his expertise, the level of recognition he has received. I'm not going to read out the whole thing, but I thought I'd read some of it because I really want you to get a sense of the privilege we have in this kind of having this expertise available to us today. Professor Ramana serves as the UMBC site director for the NSF Industry University Cooperative Research Center, BRAIN. The acronym stands for Building Reliable Advances and Innovations in Neurotechnologies, and leads the Sensory Motor Control Laboratory. His research focuses on sensory motor control, brain-computer interfaces, rehabilitation robotics, exoskeletons, human-robot collaboration, and neurotechnologies for rehabilitation and mental health. Dr. Binja Mori's research program is supported by multiple federal agencies, foundations, and innovation programs, including the National Science Foundation, the National Institute on Disability, Independent Living and Rehabilitation Research, the United States India Science and Technology Endowment Fund, the New Jersey Health Foundation, and several UMBC innovation initiatives. In addition to his research leadership, Dr. Binja Muri plays an active role in interdisciplinary health research and academic collaboration. He serves as the director of the Cyber and AI Core within the University of Maryland, Baltimore, UMBC Institute for Clinical and Translational Research, where he supports clinical and translational research. He is also an affiliate faculty member of the Public Health Research Center and has various other recognitions and honors to his name. So and there's more to this, but I just hope that gave you a sense of how much expertise, and experience Professor Binja Muri brings to the table. So Professor Binja Muri, welcome to the session. We're really excited to have you here and to hear about your work in this field and to learn more about human-robot interactions. Over to you.
Thank you so much, Deborah. Thank you for inviting me for this event. Also to your team, Rupali and Amita, if I recollect the name right, because the name disappeared from the list. Thank you so much, you guys, for managing this event. And I'm also super excited. I can easily see more than 100 people in the audience already joined, and there are more joining. I'm really excited. Thank you so much. So, are you able to see the screen? Are you able to see the title slide?
Yes, Professor, we can.
Okay, perfect. So today, first of all, good evening, everyone. Good evening to you. Good morning to me. So today we will talk about human-robot interaction, HRI in short. I'll be using that quite often. This is basically the science of teaching humans and robots to tolerate each other productively. So robots are actually becoming part of healthcare, homes, transportation, entertainment, and even emotional support systems. So the big question is no longer can robots work? The question is can humans and robots work together naturally and safely? So much of my lab's work at UMBC, and thank you, Deborah, for that long introduction. It was quite embarrassing for me. So my lab's work at UMBC focuses on this intersection of robotics, AI, neuroscience, rehabilitation, and human behavior. Okay, so let's take a dive and let's see what you guys can take away from this. All right, so first off, why HRI? Why human robot interaction, right? For many years, robots lived safely inside factories, behind big cages, assembling our cars, right? And honestly, I can say that humans were probably more dangerous back then, right? So now robots are entering hospitals, schools, airports, homes, and potentially your kitchen, right? So that totally changes everything. So HRI, human robot interaction, it combines these areas, very multidisciplinary areas of robotics, AI, psychology, neuroscience, and design. So in other words, this field is where engineers like us are finally realizing that humans have emotions, right? So the goal is not replacement, the goal is collaboration. How can we collaborate effectively with robots? So what is HRI, right? What is human robot interaction? So HRI studies how humans and robots communicate, cooperate, and build trust. So it is like matching, it is like matchmaking, right? So a technically perfect robot can still fail if humans find it confusing, creepy, unpredictable, and annoying. That still can fail even if it is a perfect robot. So human robot interaction is not only about making robots smarter, but it is about making interactions intuitive, right? Think about self-driving cars, right? The hardest part is not just driving, it's understanding humans, pedestrians, drivers, cyclists, and sometimes Mumbai traffic behavior, sometimes New York traffic behavior, right? So if you look at how these robots have evolved over the years, we've seen industrial robots for so many years, right? So we moved from industrial robots doing repetitive tasks, like putting together your cars, right? Or now into construction robots, right? Now, from there, we have seen a transition to collaborative robots or cobots. They're sitting at your desk, they're working with you. So these are working besides humans, right? Earlier robots, they followed rigid commands, but modern robots, they can actually adapt and learn. Okay. And also, we also move from pure automation towards share autonomy. So we both share control. That means robot helps you rather than replacing you completely. So robot takes some control, human takes some control, right? Think of GPS navigation, right? It suggests routes, but thankfully it still lets you ignore them and drive into traffic anyway, right? So it will just suggest. So it is like that. So this is how human robot systems have evolved over the years. So now let's move into let's see this thing. So now let's move into the core components of human robot interaction. So these are some of the major building blocks of human robot interaction. The first one is perception and sensing. Second one is human intent recognition. And the third is shared control and autonomy. And you will see these other topics being interleaved in the above three as well. So let's take a look at um, the first three in a little bit more detail. All right. So these are, I can say, as the major building blocks of human robot interaction. So the first one is sensing. Robot needs to perceive environment, right? And the second one is intention recognition. Robots must estimate what humans want. And third is shared autonomy. How much control belongs to human? How much control belongs to robot? And somebody has to decide that. And of course, communication, 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 that's everywhere, right? We all need to communicate with each other effectively and likewise with the robots. If any one of these things fails, then collaboration breaks down very, very quickly. So that's why these are all really, really important. And also, I can say these are the core topics for human robot interaction. So the first one is robot sensing and perception. So in our lab, we use multimodal sensing. We record from people, from their muscle signals, from their brain signals, from their behavioral signals. Like, for example, your Fitbits, recording your heartbeat, heart rate variability, skin temperature, sometimes sweating. We can record all these. Motion capture, computer vision, and also physiological signals that I spoke to you previously. So why do we need these many signals? Why multimodal? Because humans are complicated. If someone says I'm fine, physiology may strongly disagree, right? Somebody may say I'm fine, but then on the Fitbit, you're clearly seeing that their heart rate is out of the charts, blood pressure is out of the charts, stress levels are out of the charts, right? So we use AI and multimodal data fusion to estimate emotional states, stress, movement intention, and engagement. Okay. So the robot of the future is not just seeing you, it is actually interpreting the context. So that's exciting, but that's also slightly terrifying because the robot that is sitting in front of you, it's reading your mind. Okay. So it's slightly terrifying. So some students ask me, what do I do for my research? And I tell them that we are developing technologies to read your minds. And these students, they've stopped making eye contact with me. So whenever I see them in the corridor, they don't even look at me anymore. So it is somewhat terrifying as well, right? All right. So let me give you one example of robot sensing and perception, right? So this is one of the basic examples that I can start with. If you want to control a robot, how can you do that, right? If you want to control a robot, um, let me get out of that. Yeah, okay. If you want to control a robot, you can tell that to go away from you or come closer to you. There are several ways you can tell a robot to do what you intend to. So here's one example from our lab. This is Kinova robot, and this is a robotic arm with a claw being controlled by my PhD student simply by using gestures, right? So you're asking the robot to come closer or go away, right? Come closer or go away. You can do these gestures and you can control the movements of the robot. This is one of the easiest way, right? So you can use basic computer vision. You could use a simple camera like your webcam on your laptop, right? You don't need super scientific cameras or um, high-end technologies, just some webcam, computer vision, and we can follow our movements and you can command robots. So this is one easy way to do this, right? Okay. All right. So, but there are other complicated ways, other deep layered ways to let human intent recognition. And so a major change in robotics is predicting what humans intend to do. And that is also a challenge, right? So humans are actually very good at this with each other, right? If someone reaches for coffee, you know what's happening, right? So they all work together, so, right? So, but robots struggle because humans are noisy, non-linear systems with emotions, distractions, and also coffee dependency, right? So how do we manage all this, right? So if the robots are smart enough to understand your emotions, right, they are better off, right? So how do we do that then, right? So here, another quick example video to show. First, I'll let you watch this video. This is again my PhD student, Farshad Safawi, who's trying to control the robot that you see in the back screen, right? It's mounted to the table um, by his emotions. If he's happy, the robot will move faster. If he's sad, the robot goes back to the reset position. If he's happy, the robot moves faster towards him, right? So think of these cobots, right? These are collaborative robots. That's what I told you in a previous slide. These are the robots that are sitting at your desk and working with you. These are no more caged somewhere in some industrial setting. These are sitting at your desk and they're working with you. Okay. So now, if there are such robots, and let's say you're working 5, 10 years from now, let's say you're working in a chemical company, in a fertilizer company, all right, and it is 9 p.m. You're very, very drowsy after that long day of work, and you're very, very stressed out. Okay. And at that time, this arm is coming towards you and it is holding a very, very hazardous chemical and it is coming at you. Okay. Imagine that. Okay. If the robot knows your states, your emotional states, your stress states, your sleep states, it can stay away from you, right? Right? It can stay away from you. So so how do we let the robot know our emotions? So one way to do that is using facial emotion recognition, right? And that's what we demonstrated in this video. This work was published in IEEE Transactions and Affective Computing. You can all download that and read that as well. So here we used facial emotion recognition, only facial signals, again using a simple webcam, all right? So here we see that facial emotion recognition, right? So we're trying to capture the facial emotions, right? And we are trying to control the arm, right? As a proof of concept demonstration, right? But unfortunately, the state of the art accuracy in facial emotion recognition is only 70%. Why? Because we are very, very good at hiding our emotions, right? We are very, very good at hiding our emotions. So if that is the case, then of course, any system cannot predict or cannot estimate our emotions, right? So that is a huge challenge that is a huge challenge, right? So then what do we do, right? So we have some answers, all right, that I'll share with you in just a second here. The next topic, the third one, again, core building block is shared autonomy, right? So humans and robots, they are now jointly contributing to task completion. So both are working, both are working simultaneously. Robots assist while preserving human agency, right? So humans should not think that it is not in their control, that the robot is going crazy, it is not in their control. Humans should not think like that, right? So um, some of the examples of these are prosthetics, surgical robotics, assistive exoskeletons, right? So these are the places where sense of agency should not be lost, right? The users should think that this robot is theirs. They cannot lose that ownership. They cannot lose that sense of agency, right? That is very important. So there's always this trade-off between user control and automation. How much control do we need it to be given to the robot? Okay, so I'll give you another quick example. This is another robot that we developed from our lab. This is called Hexos. This is a hand exoskeleton embedded with synergies. So let me show you some examples here. So we're trying to control this exoskeleton with muscle signals using very simple neural networks. These are not even deep neural networks. These are very, very simple neural networks. So here we show that a simple hand exoskeleton that we developed in our lab, 10 degrees of freedom, meaning 10 dimensions. So 5 fingers, 2 dimensions per each finger. And we are able to pull these for flexion and extension using motors called linear actuators. So you can see that in the video as well. Um, just for time constraints, I'm going to push this forward, and I'm going to show you that using wireless muscle signals, we are able to flex the joints of the exoskeleton. So this can be used in individuals, for example, with hand paralysis. They can actually grasp objects, and that can be controlled by their other arm or by using facial EMG, etc. So there are 100 ways to do this. But this is one example where it is a shared control, right? Let's say somebody has partial paralysis. So they have some movements in their hand, right? But the exoskeleton is also helping them move. So how much the exoskeleton moves and how much their own hand moves. So these are some of the questions that we're trying to answer by estimating the level of movement that is left in individuals with paralysis or partial paralysis. Okay. Next up, we are also trying to develop environments where we can actually teach people how to move. This is also, again, for example, like physical therapy, right? Physical therapy or movement rehabilitation, post-stroke or spinal cord injury, if somebody has paralysis, and if they're going through physical therapy to regain their movements. So how do we do that? So this is one example where we are developing these immersive virtual reality systems. What you don't see in this video is we now have head-mounted displays for immersed virtual reality systems. So here we are able to track movements using that small sensor that you see on the desk. This is an optical sensor that tracks your movements, and it'll clearly render them in a virtual reality environment. So we can definitely use this for individuals who have partial paralysis. They can move their hands to the extent they can move, and we can train them in this virtual environment. If they have total paralysis, then we can use the exoskeleton that you saw in the previous video, and we can train them in moving their hand, okay? So, as you see these topics, you see that humans and robots are collaborating, right? So, human robot collaboration means humans and robots working towards shared goal. In those examples of flexing your hand or extend your hand or grasping some objects, so you're working towards that shared goal. So in manufacturing, this may mean lifting heavy objects together. For example, Amazon warehouse workers or soldiers that are deployed in difficult war zones. They are lifting heavy objects and carrying them for a while. You can also think of these for nurse practitioners who are lifting people. If you do it once, it might not affect you, but if they're doing it 100 to 1,000 times per day, that affects, right? So can we help them with exoskeletons like body suits, etc.? So in education, it may mean socially interactive tutoring systems, right? So the key ingredients here, they are trust, predictability, and safety. So these become really, really hot topics because this is like, again, working with a mate, working with a friend, working with a person, working and collaborating closely with a person, right? Um, so when we are talking about these topics, brain is one of the important centers in human body that that communicates decision making, that is the center of decision making, and also for coordination, collaboration, or competition, you may say, right? So this is one of my favorite areas, brain-computer interfaces. They create direct communication between neural activity and machines. Okay. So for robots to get human intention, this is another way to do that, and that is using brain signals. So let me play this video. This is also in our lab where somebody is wearing that brain cap. And so you can walk into our lab and we can put this brain cap on you. This is totally non-invasive, totally safe, and we can start recording your brain signals. You see, we can decode up, down, whenever that says D, that's down, left and right from the brain signals of the person that is sitting and controlling, and we can easily control this robot, navigate this robot in up, down, left, and right directions. All right. Um, and so that's right and left. So I'll just skip the video. Um, and so another important concept in this robots coming together is AI and learning in human robot interaction, right? So modern robots, they're increasingly learning from demonstrations and interactions. So we use machine learning, reinforcement learning, and multimodal transformers, right? And the challenge is generalization. So a robot, it may work perfectly in the lab and then become confused by real world lighting, noise, or humans doing unexpected things around them. Okay. So let me show you another video. And this robot that you see in the video is actually from Bangalore. And this is one of my students is teaching the robot how to move, and this robot is called Mitra. This was actually inaugurated by Prime Minister Modi and Ivanka Trump in one of our Republic Day events, January 26th events. And this was way back in 2018. All right. And this robot is called Mitra. This is from a company called Invento Robotics. The CEO is one of my students from UMBC. And so in that video, my student is actually going in front of the robot, moving, right? And the robot is looking at those movements, imitating those movements, and that way it is learning those movements. All right. And believe it or not, we're talking about these as some futuristic robots, but this robot, this very same robot, 2019, right? 2020, 2021, 2022, this robot helped close to 100,000 COVID patients. This robot served as a hospital receptionist during COVID. So many applications of these robots already in our society. All right. So next up are social and affective robots. Okay. Social robots, they focus on emotional interaction. These robots estimate emotion using speech, facial expression, movement, and physiology. So this has huge applications. We cannot, this is endless. Okay. In therapy, education, elder care, mental health, and um, there's tons of applications for these type of robots. So, but there is a balance. If robots become too human-like, people become uncomfortable, right? And so, um, so apparently humans want robots to be emotional, but they don't want them to be too emotional. All right. Okay. So, for this, we are developing robots, and this picture is from our lab. We are developing robots that can dance with you, and this we are using this as a tool for mental health disorders, as in schizophrenia, bipolar, and several other major depression disorder, etc. Okay, and this is one project that was in our lab, and this is called Shivam, and this is actually inspired by Shiva, the Indian god of dance, right? So this project is Shivam, where we combine humanoid robots, dance movement therapy, and all the physiological signals we talked about, also skeletal movement tracking. And the idea here is to improve engagement and emotional well-being through dance movement therapy. And when we entered this project, we were engineers, right? We are engineers, and we didn't know how this will be received. And dance is a universal human language. And when robots are dancing with humans, it turns out to be a surprisingly a powerful engagement tool. And also robots don't complain about rehearsals. So that's another good thing. Okay. So I'll show you some pictures, but in the next part of the talk, I'll show you some of the videos from this work. So here are two dancers. We are tracking their movements using very, very low cost cameras. And also in part two of that performance, we tracked one of the dancers' brain activities, their emotional states, etc. Okay. So when we are talking about social robots, talking to your brains, interpreting your thoughts, something that becomes really, really important is trust and explainability, right? Trust is central to human robot interaction. If humans don't understand why a robot made a decision, trust breaks down, right? But too much trust is also dangerous. So humans tend to overtrust automation surprisingly quickly. All right. Whenever you're stepping into elevators, how many of you check the expiry date on them, the maintenance dates on them, right? Humans tend to overtrust automation, right? Some people treat autocorrect like divine wisdom, right? You all have experienced that, right? So explainable AI becomes extremely important in healthcare and robots, right? And robotics, assistive robotics especially, because we don't want these black box models doing something and giving an output, right? Explainability becomes really, really important. What are the signals that you put into the model? What is the decision that you made ultimately? So this becomes really, really important. And the last but not the least is safety in human robot collaboration, right? Safety is not only physical, right? Yes, of course, robots should avoid collisions, etc. But psychological comfort matters too, right? Psychological safety is also really, really important. A socially assistive robot that makes users anxious has failed. Even if it is technically correct, it has failed, right? So we must also address ethics, privacy, fairness, and also transparency. Um, let's say we were all sitting in a room, Zoom rooms, kind of impersonal, but it's good that at least we have a platform that I can talk to you guys while I'm in the US and you're all in India, right? Or some of you maybe in the other parts of the world, right? But let's think that you're all sitting in a room, in a classroom, and I'm giving you this lecture, and while I'm walking around, I'm actually able to read your minds. Okay, how comfortable will you be sitting in that room? Right? So, exactly like that, if there's a robot that is next to you and it is continuously reading your thoughts, what thoughts is it reading? What is it not? Right? that becomes a policy, right? That becomes something serious that we have to consider, right? So that's where ethics, privacy, fairness, all these topics come into picture, right? All right. And some of the future directions, the future of robotics is deeply human-centered, right? We will see personalized collaborative robots. Healthcare robots will expand dramatically. BCI, brain-computer interfaces, and robotics will become increasingly integrated. So we are actually moving towards ecosystems where humans, AI systems, and robots, they are all collaborating together and coexisting together. So that's all happening. The next decade will likely redefine what we mean by intelligence and teamwork. All right. Some discussion points. Um, these are intentionally difficult questions. Should robots make independent healthcare decisions? How much autonomy should robots have? Can humans emotionally bond with robots? I mean, many people already yell at ChatGPT or apologize to Alexa, right? So I think we already know the answer for some of these questions, isn't it? Right? So in closing, just to close this part of the topic, um, human robot interaction is fundamentally interdisciplinary, right? The most successful robotic systems are not necessarily the most autonomous systems. They are the most collaborative systems. And trust, adaptability, human-centered design, right? It's not like the olden days where these huge robots are sitting in cages, right? These are working with us in the society that we live in, right? So then human-centered design becomes extremely essential. The future is not humans versus robots. It is actually humans with robots working collaboratively. Okay. All right. So that's the first part of the talk that talks about fundamentals of human robot interaction. All right. And the second topic that Deborah asked me to speak is the U.S. at the frontier of the robotics. So now let's zoom out and talk about global robotics landscape and where the United States fits into this rapidly evolving ecosystem. Right. So you listen to news almost every day these days about AI, right? AI, when you read about AI, when you think about AI, you might think of that as a software, right? But what is AI, right? What is AI in person? What is embodied AI? If you put a body around that AI, that becomes a robot, right? So embodied AI are robotics, all right? So so let's ask this question, where the US leads in robotics. So the US leads very, very strongly in AI-driven robotics, medical robotics, neurotechnologies that are controlling robots, aerospace, and there are lots of startups that are building these robots now. All right. And the university to startup pipeline in the US is extremely powerful. Many, many major robotics companies, they emerged directly from academic research labs. Okay, so let me quickly list some of these major US robotics companies that are really making trendy robots, cutting edge robots. Some of these we have used already. Boston Dynamics actually made the robots really, really cool. And that's one picture that you're seeing. Tesla wants humanoid robots in homes and factories. NVIDIA is is really becoming the operating system of AI-driven robotics. And there's also Intuitive Surgical that is actually transforming surgery. And we're now entering the era of general purpose humanoid robots. And so this is either the beginning of a robotics revolution, or you can think exactly, I'm going to borrow Deborah's words, like the opening scene of a science fiction movie. This is not fiction anymore. This is reality now, right? Agility Robotics, Figure AI, and Sanctuary AI, they're building the next generation humanoids. And they're all powered by AI. There's also some pioneering US university labs. Universities remain major innovation engines. MIT Robotics, AI, soft robotics. Um, MIT leads in these topics. Carnegie Mellon University, autonomous systems and field robots. Stanford University is doing a lot in AI, manipulation, and also autonomous driving. I have a dear friend and colleague who is a UMBC graduate who is at Stanford, who is working on grasp and manipulation. Hopkins, which is about 20 minutes from us, is probably the pioneers in surgical robotics with their Da Vinci and also neuroengineering. And Pitt, this is the lab where I got, this is the university where I got my PhD from, and also the lab there working on neuroprosthetics. Um, and our lab, we are contributing in our own way. At our lab, we focus on human-robot interaction, rehab robotics, and neurotechnologies. So this is the exciting part in the robotics, that it is no longer isolated. It now requires neuroscience, psychology, AI, healthcare, ethics, all of them together, right? So this is also something really exciting that you may want to learn is US-India robotics collaborations. India and US have enormous collaborative opportunities. India brings scale, talent, healthcare needs, and rapid innovation ecosystems. And the US contributes to research infrastructure, translational pipelines, and startup ecosystems. So there's a huge opportunity in rehab robotics, affordable healthcare robotics. So that is really, really important. Let's say I made my exoskeleton, and let's say that that exoskeleton costs 10 crores, right? Nobody's going to buy that in India. Even in the US, nobody's going to buy that, right? So cost affordability it becomes an extremely important issue, especially for healthcare robots, right? AI systems and also neurotechnology. So this is a huge opportunity, right? And also talking about some of the grant opportunities. I've actually collaborated with India. I'm a visiting professor in IIT Hyderabad, and I also have very close collaborations with NITs and other private universities in India. So we work on rehabilitation technologies with Manipal University, and that work was actually funded by USISTEF, United States India Science and Technology Endowment Fund. All right. So and there's also several opportunities that I'm pursuing right now. Fulbright scholars can actually come work in our laboratories, when we can actually go and visit India and Indian laboratories. This February, we actually offered a workshop called GIAN, GIAN. This is Ministry of Education supported, Indian government Ministry of Education supported workshop, which we offered at NIT Trichy. This was about human machine systems and how you can control them using your biosignals. So you can participate in any of these workshops and these opportunities. And also something else that I wanted to share is we build control algorithms, but there was a collaborator in Assam who was building prosthetic hands for people with disabilities coming from lower economy. And so they could not afford. So they were 3D printing these prosthetic hands. And so we worked with them. We provided control algorithms for near natural control of prosthetic hands. And that was supported by National Science Foundation on the US side and DST, Department of Science and Technology, on the India side. So these are some of the amazing collaboration opportunities between India and US. So talking about future of robotics, I think we already covered this topic in the other part, but the future will likely include collaborative humanoids, adaptive AI systems, and personalized healthcare robots. We will increasingly see robots working alongside humans rather than independently replacing them. You see a lot of robots already at the airports, at the clinics, at some universities, at hospitals. You're already seeing them, right? The winning systems will combine intelligence with empathy and usability. So these are keywords that you need to remember. If you talk about future of robots, there are two things that I want to share with you. Those are technologies coming out of our lab. The first one is Shivam. You saw some of the pictures already. Here are videos showing you the two dancers enacting their movements. And I don't know if you can see this clearly. Their movements are being tracked and they are being relayed to virtual avatars dancing in the virtual environment, right? So this is part one of the performance where we are trying to mimic their movements and put them into virtual robots. And here's the second one where for one of the dancers, you see how we are recording brain signals. We are recording one of the dancer's brain signals and we're displaying those signals on screen. And right on the right top, we are also estimating their emotions. This was one performance where we showed interbrain synchrony and how two people can work together. And in the next performance, we are trying to introduce robot instead of that person to see how humans and robots can work together. This is still a work in progress, but I want to show one of the videos that we just released last week. All right. So the second project, this is Synergy. Core of our lab, what we do is we study hand movements and we study alphabets of hand movements. And so we usually study hand movements from normal people, like all of us, right? But if some of you are dancers, okay, some of you are dancers, we study movements from dancers to 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 record superhuman alphabets, okay? Superhuman alphabets of hand movements. And that's what we did in this study, and we became really, really popular, is we recorded hand movements from classical Indian dance form, Bharatanatyam. We actually have a dance professor who works with us. She's a Westerner, um, but she actually told us to go study Indian classical dance form, Bharatanatyam, to actually get those mudras or hand postures. And from that, we can extract superhuman alphabets of movement. We are recording those superhuman alphabets and we are putting them into robots in our lab. So this is a hand robot. These are two humanoid robots. We are trying to put these alphabets of movement that we recorded from Indian dance form Bharatanatyam, and we're putting those into these robots. So if you want to read about it, we don't have much time. I'm already very close, just 3 minutes to end this. Um, so you can take a look at some of these articles if you Google robots, dance, Vinjamuri, put my name in there. You will get a lot of these articles that you can read about. Okay. So some of the skills that are needed to be in these future markets, right? Students entering robotics today, they need multidisciplinary skills, right? Yes, coding and AI matter, but multidisciplinary skills, communication, psychology, neuroscience, ethics, entrepreneurship, design, all these matter as much as coding and AI. Okay. So the next generation of roboticists must understand humans, not just machines. So this is a big pathway leading forward. Okay. So some final thoughts. The future belongs to interdisciplinary innovators. So far we were thinking that coding will take us end to end, big paychecks, etc. Now all that coding is being done by AI. Big chunks of all the IT companies are now replacing people with AI, right? So the future of this human robot interaction, the future belongs to interdisciplinary innovators. So the most impactful robotic systems will be those that enhance human capability, dignity, health, and well-being, right? And honestly, if robots eventually take over PowerPoint presentations, I hope at least they keep the animations real, right? And tasteful. All right. So thank you so much for this opportunity. I'd be happy to discuss some concepts of robotics, AI, neurotech, some collaboration opportunities with you guys, and I can tell you why we're still better than robots. All right. All right, and this is a hi from Vinjamuri Lab to all of you. All right, and maybe some questions, and this is how you can connect with me. Thank you.
Thank you so much, Professor Vinjamuri. That was amazing, amazing overview. And even for me as a non-technical person, I really enjoyed the very exciting nature of this field. It's a brave new world, as they say, and there's a lot going on and a lot to come as well. We're going to take a few questions now. So we have some questions coming, and I'm going to read them out. And students, if there's time, you can still ask questions, and if there's time, depending on time, we'll take as many as we can. So the first question is, what is the impact of emerging legal ecosystems by the government, in terms of either helping or hindering the development of research in robotics?
Good question. So, as much as technology is important, policy is also important, right? Government agencies, regulators, monitoring the development of these technologies is also important. I'll give you an example. We're trying to build training platforms for nurses in our University of Maryland Medical Center. And one of the requirements is that these AI systems that we're going to be using for teaching these nurse practitioners, they should be Title II compliant or ADA compliant, right? American Disabilities, right? So now, if we put such restrictions, then we are hindering training, but at the same time, we are not stopping the rate at which the technology is evolving, right? So we cannot stop because you need to compete at a global landscape, right? You cannot stop that competition. But at the same time, you also have to evolve the policy and the industry, the makers of these AI systems, they should be responsible. That's why, and that's why I really like this question. It is very important, is that when we are developing these technologies, we need these multidisciplinary experts to be serving on those teams. Ethics, privacy, all these concerns should be evaluated simultaneously without hindering the progress of the technology, of course. Yeah. Great question. Thank you.
The next question is, do I use physics-informed digital twin for future robotic development, and how is it helpful?
So now a lot of neural networks, the way we started with was what is called machine learning, artificial neural networks. Now we are seeing deep neural networks. But then there's also a new term, not new anymore. The pace at which AI is developing, not new anymore, is physics-inspired neural networks. Using these physics-inspired neural networks, we are able to model digital twins, okay? And we are, honestly, I'll tell you this, we are scratching the surface. We are no way close to um, we are good at branding, but we haven't developed enough, right? So digital twins, we are very, very far from actually twinning you in a cyberspace, right? So, and again, it is at different levels. Do you want to replicate your movements? Do you want to replicate your speech? That we can do, right? But do you want to replicate your um, biological system? That digital twin, people are working on it, but it is extremely difficult to model such systems, and we're literally only scratching the surface at this point, right? We have huge brain projects, I'm sure you might have heard of, where we are replicating human brains on computers, supercomputers, etc. But again, taking all those resources, we are only able to model um, a mouse brain. We are no way close to modeling human brain. Um, so stay tuned, right? This is exciting. This is where you all can contribute. Yeah.
Thank you. Just a quick note. In a couple of minutes, I will change the slide to some Education USA India contact information as well. So for now, if any of you want the QR code and the link on this slide and any of the other contact information, do quickly take a screenshot or scan the QR code, etc. Because in a little while, I'll put up the Education USA slide too. All right. Next question. Humanoid robotics is advancing rapidly, but concerns around bias in facial recognition and behavioral decision making remain significant. Do you think these challenges can realistically be solved with current AI approaches, and how do you see AGI changing the capabilities and risks of humanoid robots?
This is again a very, very good question. Um, we did see computer vision systems. We did see cameras capturing human emotions. There were inherent biases in the algorithms that were used. We did see that 2020, if you go back to the news, you will see them all over the place. So we did see those. And since then, we have made several correction courses to these technologies. And that's why this is really, really important is these deep models, they will actually help us. Um, these larger models with several layers with million, billion parameters, they are um, they're actually helping us in capturing the variance in the data, the diverse data that we get. So hopefully with these technologies, we can reduce bias in these systems, and hopefully we can develop better technologies. And all those technologies that we can put on your cell phone, your smartphone. Okay, we don't need big servers to handle all these. Yeah.
Thank you. In light of time, we will just take two more questions. I know there are a few more which have come in, but I don't know if it's all right, Professor, if we can reach out to you via,
Absolutely.
and or you can reach out to us as well. We can't answer questions on robotics, but if there's any other kind of question, we can.
No worries.
Um,
Connect with me on LinkedIn. I'm happy to
yeah.
continue. Yeah.
All right. So one question from a research perspective is, give me a moment. Just trying to take this in order of those that were asked. All right. Sorry, just give me 1 second. Yes, okay. So this is actually from an education perspective. What path would you suggest for an undergraduate student in computer science and engineering to build a better career in robotics? I have already started my journey by learning ROS and Gazebo, and I would like to know what I should focus on next.
Good question. So, I think hearing your question, I think you're already set on the right path. ROS and Gazebo, these are very good simulators and operating systems that you need to learn to control the robots. But also take some multidisciplinary courses. That's my suggestion. Take a course in brain-machine interfaces. If it is not available at the university that you are studying, you can do a lot of online courses. They're all free. MIT Open Courseware, Stanford Open Courses. If you reach out to me, I'm happy to share some of my lecture materials as well. Try to take interdisciplinary courses, psychology, neuroscience. Um, this is addressing the field of these robots interacting with humans, and that's the future.
All right, and one last question from, again, from the same perspective. For pursuing robotics in the way that you have described, what would you recommend as a major to pursue, mechanical or electronic engineering?
That's another good question. That's why the walls are breaking now. So there's no more. So remember how we started, right? Maths, physics, and chemistry, and then we combined all those, and then we got all these engineering areas, right? electrical engineering, we just don't study math, physics, chemistry. We study all of them together, right? Um, Similarly, biomedical engineering, extremely interdisciplinary, right? So it's not just one area. It doesn't matter what area you're in, right? You might be seated in electrical engineering. For example, all my degrees are in electrical engineering, the way I started, right? All my degrees are in electrical engineering, but my postdoctoral research was completely in biomedical engineering. And my PhD was in a very interdisciplinary research area. So, and there's no more walls, okay? And even if you're in mechanical engineering, you can still study signal processing, machine learning, and AI. That will make you better equipped for the future. But these are excellent questions. Thank you.
Thank you, Professor Ramana, for this really wonderful session. Absolutely enlightening, exciting, fascinating, engaging. And thank you, everyone, for your participation, for being here, and for asking such wonderful questions as well. For now, we wish you a good morning, a good day, Professor, and good evening to all of you who are joining in from India. And do feel free to reach out to us with any follow-up questions that you may have, and also stay tuned for more sessions like these in the near future. Thank you, everyone, and all the very best with your academic and research journeys.